everyone, welcome to the channel Knowledge Star, Continuous Knowledge Excellence. My name is Nisha Masroor. In this video, we will get to know about gelatin nanogels for MRI. Now, our expert Professor Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Terry Daikon Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics and biophysics. We'll explain you in detail about this topic. So, to get complete information, watch full video without a skip.
This is gelatin nanogel for MRI. MRI, is a very high contrast instrument which is used for imaging tissues deeper inside the body. Okay, but there are problems often because of the contrast and the issue of the blood-brain barrier. So many times the people come across difficult situations where it can be used and where it cannot be used. So there are finer restrictions and boundaries here and there. Now, to resolve this issue, this particular experiment was done where gelatin nanogel was used as a carrier to increase the contrast of the MRI by loading or by delivering the contrast agent at the imaging site. Okay. Now realize that for MRI experiments, unlike what we saw earlier in the transdermal drug delivery, we need to have much smaller size particles. So this particle size here typically about 10 to 15 nanometer, 20 nanometer. And clearly the template model that we are following, that will not succeed in giving us a 6 to 21 nanometer particle size gelatin nanogels. Okay, so the different synthesis protocol has to be adopted now. Okay, so gadolinium happens to be one element which enhances the MRI contrast. There are strong scientific reasons for that. I will not go into details of that. But if it is gadolinium is present, then the MRI contrast is always enhanced. The signal to noise ratio improves dramatically. So it's basically now to make a precursor, polymer precursor containing gadolinium. So GDGN nanogel has to be made now. Okay, then this will be tested for the MRI experiment for contrast enhancement and see that it doesn't really create any toxicity to the subject, and the material is excreted from the site within a definite amount of time, and there is no accumulation in liver or anywhere else. There should be a synthesis. Yeah, first synthesis. The sequence has changed slightly. So as I said, gadolinium is actually high contrast agent you use for MRI applications. So here we make a gadolinium containing nanogel. So the synthesis process is the following. This starts with a nanogel. Let me see the first one. Let me start with this one. So we have a gelatin solution, 15% in water. You radiate with gamma rays here. Because gelatin is a amino acid sequence, they absorb gamma rays very effectively. This will immediately cross-link the gelatin chains. If you wish to do additional cross-linking, you can add a chemical cross-linker like glutaraldehyde there. But this will also work in the absence of glutaraldehyde, and we can follow the chemical cross-linking route. No addition of glutaraldehyde. In both cases, we have to irradiate it with gamma radiation. Either, see, we had done physical cross-linking, we had did the chemical cross-linking. Now, we can directly go from there and now create the gelatin gel.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, The registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
So basically you take the 15% cross-link gel here, then added it to a GTA with a concentration of 0.6 weight percent, reacted at low temperature, that creates the chemically cross-linked gel. In the next step, the gel is added to glycine 100 millimolar per DMQ to remove the inactivated GTA from there. Then you wash it with molecular water and your gel is now ready. So either you have a chemically gel or physical gel, one physically cross-linked, one chemically cross-linked here. Now we have to go to the gadolinium linking to it. This one. So we have the synthesized nanogel with us. So the synthesized nanogel in water is added to this concentration of DOTA. DOTA is a very long name here. UPSC name of DOTA is written here. It's a long chemical name. NHS also has a long chemical name here. It's hydroxysuccinamide. So gelatin nanogel in water is now added to DOTA NHS ester and DOTA butyl amine aqueous solution, and just stay in the incubator for about an hour. Add gadolinium 3 chloride solution, certain concentration to this, what we have made earlier at 40 degree. Leave it for 3 to 4 hours for it to come to an equilibrium. Wash it with DOTA again to take out on the reacted unloaded solutions. And then you have a pure GD loaded nanogel ready for you. This synthesis process looks little, there are many steps in it, but it's a very simple process because you see there is no extreme reaction conditions anywhere. We're still dealing with 40 to 50 degrees Celsius, and most of the chemicals that we are using here are non-toxic chemicals. Okay, now once the gel has been formed, this is the analysis of the size or the control as a function of different input parameters. One is the radiation of the gamma ray. So if you use a larger gamma ray radiation, then you can see the cross-linking is more and the particle size increases from starting from a 10 to 20 nanometer going up to 150 nanometer. Okay, now for a given radiation, given concentration of gelatin, higher temperature, you see a smaller particle size. 50 degree, the particle size is close to about 10, 12, 15 nanometer. Whereas for 0 degree, you see a much higher size. So it also depends on what conditions you are doing the radiation to it. So these are very sensitive to the experimental condition. Now you would also see the gelatin of different molecular weight, keeping the radiation constant, concentration constant. See here, for a low molecular weight gelatin sample, we have a smaller size gel, 6 nanometer. Higher molecular weight, 3 times higher, 20 nanometer. So if you increase it further, it will go to the. So all these are design parameters in the synthesis of the nano gel of gelatin containing gadolinium sample. These are the 10 pictures. So this we have discussed already. Now this is the cell viability test of the gadolinium, and you can see that it really does not create toxicity even after a long time, 24 hours. It's a little flat. Now average size of the particle, nanogel particle in PBS buffer, water, or in the serum, up to almost 10 days, particle size no change. So basically it is stable against all this environment. To various media, the particle is very stable. So that actually increases the usability or feasibility of using it as a bioimaging agent in the real life applications in MRI.
I hope you like this video. Further, I would like to give you an important information that Nanoscience and Technology Consortium organize the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC, in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. Subscribe to the channel on Star and also hit the bell icon to never miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.